Here's a useful result concerning the variance of a random variable, which you've probably seen in your stats class. For random variable x, the variance is defined as this thing here. Show that this expression. Now the thing is that this expression on the right hand side is easier to calculate than the expression on the left. Let's see why. Okay, this table shows us why this right hand side expression is easier to calculate than the left. Random variable x is discrete. The left hand side expression is like this. The right hand side expression is like this. This right hand side, it is simpler to calculate than this one. It's simpler because there's slightly fewer operations we need. For this one, we need to calculate this difference and square it and then multiply probabilities. This one we just simply need the xi's and multiply by the probabilities. And it's a similar story when x is continuous. I'm going to skip the case where x is neither discrete nor continuous, because in an introductory course we won't bother with that. So now let's prove this result, and this will be an exercise in applying the expectation operator. Okay, this is what we want to show. Because we've got the squares inside the brackets, it's most natural here to take this left hand side and expand the bracket. Just to recap, what this means is when we're multiplying out is this times this plus this times this plus this times this plus this times this. And don't forget, two minuses makes a plus. So we have this. Now note that these two terms here, they're the same thing, so we could just group them together. This gives us this. Now take expectations through the bracket, like so. Before we continue, we have to recall the rules of the expectation operator. The expectation of a constant is the constant, so let's a be the constant, so expectation of a constant is the constant. A is a constant, x is a random variable. The expectation of a constant times a random variable is the constant times the expectation of the random variable. In other words, the constant comes out of the expectation sign. Now when dealing with these questions dealing with expectations, we always look out, we have to classify each term. Is it a constant? Is it a random variable? So let's look at this. X squared, that's a random variable. 2, that's a constant. Mu, that is a constant because it's the population mean and that doesn't change. X, that is a random variable. Mu squared, because it's based on mu and mu is a constant, mu squared will be a constant. So this second term we can apply this rule because we have a constant times a random variable. This third term is an expectation of a constant, so we apply this rule to give us this. Now note this is in the answer, so we don't touch it. These two we have to reduce to minus mu squared. We've already got mu squared there, so the question is, can I convert that into minus 2 mu squared? The answer is yes, because what is the expected value of x? Well, we've already denoted it, said we've denoted it by mu. Here look, mu equals expected value of x. And so the rest is straightforward. Minus 2 mu squared plus mu squared minus mu squared. Done. Finished. Now I've included more steps than you probably need to present in a homework exercise or in an exam. but I've done this so that you can see every single step. To shorten it, you could probably take out this line, and you could take out this line, or this line. For more help on stats, go to statisticsmentor.com to discuss this problem, and to see similar kinds of problems, go to YouTube page and click on the link in the description box. Thanks.